Hello everyone, welcome to the signal system class. In this lecture, we will discuss the initial value theorem used in Z transform. According to initial value theorem, if the Z transform of ft is equal to fz, then limit of ft as t tends to 0 will be equal to limit of fz as z tends to infinity. So let's now see the proof. From the definition of Z transform, we know that Z transform of ft is equal to f of z is equal to summation n is equal to 0 to infinity fnt into z to the power minus n, which implies that the value of fz, that is Z transform of ft, will be equal to f of 0 plus f of t z to the power minus 1 plus f of 2t z to the power minus 2 and so on for different values of n, that is for n is equal to 0, for n is equal to 1, for n is equal to 2 and so on. Now let z tends to infinity. So we have fz when z tends to infinity is equal to f of 0 plus 0 plus 0 plus 0 and so on, because z to the power minus infinity will be equal to 0, z to the power minus 2 will also be equal to 0 when we substitute the value of z is equal to infinity. So we have f of 0 is equal to f of z when z tends to infinity. So we can write that limit of ft when t tends to 0 will be equal to limit of fz when z tends to infinity. And this is the proof of the initial value theorem. Now let us see the corollary. That is, if the z transform of ft is fz and if f0 is equal to 0, then we have to prove that f of t will be equal to limit of z fz when z tends to infinity. So let's see the proof. From the definition of z transform, we know that the z transform of any function ft is equal to fz is equal to summation n is equal to 0 to infinity of f of nt into z to the power minus n, which implies that fz will be equal to f0 plus ft z to the power minus 1 plus f2t z to the power minus 2 plus 3t z to the power minus 3 plus so on for values of n is equal to 0, for n value of n is equal to 1, for value of n is equal to 2, for value of n is equal to 3 and so on. And it is given that f0 is 0. So we will substitute the value here of f0 is equal to 0. So we have fz is equal to 0 plus f of t z to the power minus 1 plus f of 2t z to the power minus 2 plus f of 3t z to the power minus 3 and so on. Now we will multiply both the sides by z, so that we have z fz is equal to f of t plus f of 2t into z to the power minus 1 plus f of 3t into z to the power minus 2 and so on, from which we have limit of z fz when z tends to infinity will be equal to f of t plus 0 and so on, because z is infinity and infinity 1 by infinity is 0. So we have proved that f of t is equal to limit of z fz when z tends to infinity. So this is the proof of this corollary. That is, we have proved that f of t will be equal to limit of z fz when z tends to infinity. And we have also proved the initial value theorem, that is limit of ft when t tends to 0 is equal to limit of fz when z tends to infinity. So that's all in this presentation. See you in the next presentation.